At ordinary temperature, gases expand more than solids and liquids. That is obvious because the molecular bonds or the atomic bonds between the atoms of the gas particles is way weaker than what we have seen in solids and liquids, right? So the statement says that at normal temperature also gases expands more widely than both solids and liquid. So this way, coefficient of volumetric expansion, I'll come back to this point again. We are talking about gamma, which is coefficient of volumetric expansion. It is quite independent of change in temperature for solids and liquids, but it is largely dependent on temperature in case of gases, right? So gamma, what is gamma? This is change in volume, which is delta V upon original volume, right? This is original volume into change in temperature. This is what we have studied so far. We are going to derive the value of gamma for gas, but not in a single way, straight way. We are going to use ideal gas equation, PV is equal to nRT. Okay. Now suppose there is a change in volume. There is a small change in volume due to small change in temperature T. Why we are saying so? As we have just discussed that gases change more rapidly, the volume of gases expands more even with smallest increase in temperature. So that is why let's delta V be small change in the volume for small change in temperature delta T. So the equation will be like this. If I divide equation 2 by 1, I'll get P delta T upon PV, which will PV is equal to constant. This is delta V, right? So P delta V upon PV, P will cancel out, I'll be left with delta V upon V. This is equal to NR will cancel out, I'll be left with delta T over T, right? So what we have, what do we want? Change in volume, okay, upon original volume into change in temperature. So just leaving 1 upon T here, I'll get 1 upon delta V upon V times bringing this delta T in the denominator side. This gives me 1 upon T. What is this? Change in volume upon original volume into change in temperature. So this term is regarded as gamma and it is inversely proportional to temperature. So now this is the coefficient of volumetric expansion in case of gases, and from this you can see that gamma and temperature are inversely proportional. That means if you increase the temperature, gamma is going to decrease, right, and so on.